Hello and welcome to another tutorial. We're going to continue our discussion on how to set up the native image tool as an external tool in Eclipse. And so far we've seen how to do it for Eclipse projects, right? The Java projects that you create inside the Eclipse IDE. And we said that the way Eclipse manages its projects is that it compiles the Java source files and put them in the bin directory, so you can set the bin directory of your current project to the basically as the workspace working directory when you run the native image. And we said that a better approach is actually to set the working directory to the project location and explicitly provide the -cp argument for the native image, the class path. And then we said that you have to use the project class path environment variable, which is very important, and Eclipse already is aware of all the dependencies on your for your Java project, every directory that is inside the class path. All right, now with Maven, similar thing. You open an external tool configuration, you click on this new button, you give it a name, let's say native image Maven, and you point it to, again, contents home lib svm substrate vm bin directory and then native image. Remember, native image doesn't come by default with the GraalVM. You have to install it separately. And then the working directory. So Maven compiles and then puts the stuff, all the classes, into the target classes. So instead of the bin directory, you can point it to the classes directory, target classes inside the project. So what I'm doing here, there are different ways obviously to set this up. Let's go back here, let's zoom in. One is to use the workspace location environment internal variable and give it an argument, a relative path, which is project name, and then /target /classes. And we know that if you use colon and some argument, it's actually the argument for this internal variables, and workspace location can accept arguments. And what it does is you provide a relative path to the workspace, and this whole string will be substituted. So we saw it here, workspace location. This internal variable can accept an argument, right? And this argument is the relative path to your directory from the workspace, the root of your workspace, right? From the workspace. So if you can just look at the tree view in the Eclipse IDE and then figure out quickly what this relative path is, and then the workspace location, Eclipse already knows that, right? And so you can put the working directory to the classes, target classes, and then the same thing, Java type name. This returns the fully qualified name of the class file, and then the output, the name of the binary, and then it can only be a name or a path to a file, right? Previously we said the /native /project name, which means after you compile it, go one level up from the working directory. Basically goes in the project location and then goes into the native directory, this directory called native, which is in the project location, and then creates a executable file called project name, whatever the name of the project is, or the name of the class, Java type name, etc. So the same story here. So again, with Maven, it compiles it and it puts the classes, all the packages and all the class files inside a directory called target classes. Eclipse, it puts them in the bin directory. And then basically when you specify an output file name or an output path to a file, it puts the binary in the working directory. So if you don't specify this output, it just puts the working directory, basically the executable file after compilation, it puts it inside the working directory. You can specify absolute path to here to some file, and then after the compilation, that file is generated inside whatever path that you give it. So let's head to Eclipse and try to create a Maven project. So this is our previous Java project. This is an Eclipse project. This is not a Maven project, which means the build system is the internal build system of Eclipse, right? And we know that what it means is that Eclipse creates a bin directory inside the root of your Java project, and then mirrors whatever you have in the src in the bin directory, right? All the packages, etc. And we see that any directory that is not marked as a package, is not recognized by Eclipse IDE as a package, it's not going to be inside the bin directory. Now what we want to do, we want to create a Maven directory. So we're going to go to other, and then inside the Maven, we're going to say a Maven project. and we're going to tell it create a simple project and put it in the whatever the workspace location is. Let's add it to the working set. Our working set of, I believe it's called native image. Advanced resolve workspace projects. For now, we're going to ignore it. Group ID java.native.image, and then artifact ID native image demo. Versioning, let's start with 1.0 snapshot. Packaging, we're going to say add jar. The name, description, let's leave these open. We don't want, and resolve workspace projects. We don't need to worry about that now, and finish. So this is going to create a Maven, and you see the difference between, obviously there are some differences between a Java project, a project that is managed by Eclipse, right? The build system is Eclipse, and whatever is managed by Maven. Obviously the directory hierarchy is different. Here we have src and your packages. Here we have src main Java, and then you add your packages here, src main resources, src test Java, src test resources. And then it also shows you the obviously the src directory here, and this is target, and target for now it's empty. And in the root of your Maven project, you have this POM file, which basically tells the Maven what to do. So if you're not familiar with Maven, I recommend just try to maybe Google it and understand what the Maven is. And basically Maven is a build system, and it doesn't have a Java compiler or anything, right? It relies on whatever Java or Java C you have on your path. So which Java C? Basically, it relies on the JDK that comes with your that is installed and recognized by your operating system. Maven is just a tool that uses the JDK to build your application, and the beauty of Maven is that it's independent of which IDE you use. Now, the problem with the internal build system of the IDEs like Eclipse or other IDEs is that each IDE has its own build system, like the directory hierarchy, the class path entries, and how they manage. We know that, for example, Eclipse creates a .project, .settings. So if I open up a directory here, you see we have this .setting. These are the settings that are related to the Eclipse .class path. This is only something that Eclipse IDE understands. If you try to open this Eclipse project in another IDE, they probably won't understand it. Same with the .project. This is something that only Eclipse IDE understands. So transforming, or if you create a Java project with one IDE and give the source code to another one, if they try to import it in another IDE, they most likely are not going to be successful in the first try. But that's not true with Maven, because Maven is an external build system. Now, IDEs have support for it, which means IDEs can figure out which Maven is installed on your computer, and then they just can use that Maven to build your application, right? Your Java project. And the beauty is that Maven is independent of IDEs. Maven is something that you separately install on your computer, and IDEs can use that, right? So if you have a Maven project, you can always import it in any IDE, and your IDE, obviously most of the IDEs these days, they have support with Maven. They have built-in support. So they can use Maven to build your project, and therefore you don't get any headache of the fact that one project from one IDE is not compatible with another. Now, Maven has obviously one more advantage, which is the main advantage, and that's dependency management. Maven has online repositories. You can specify a dependency on a jar file, and Maven can go and search into online repositories, and if it finds it, then it can download the jar file and add it to your class path fully automatically. And usually IDEs like Eclipse have a nice graphical view of what's going on, what Maven is doing. So I have installed Maven on my computer, Apache Maven 3.8.5. Let's quickly open up a browser and see what is the latest version of Maven. So let's say download Maven. Download Apache Maven. Maven is a project organized by, maintained by Apache organization, and the latest version is 3.8.5, which I have it here. And as you can see, my Maven home is user local Maven 3.8.5 libexec, because I'm using the homebrew to manage my Maven Whenever there is an update, I use brew to update my Maven. And then the JDK, you see Maven doesn't come with the JDK, but when you look at the -- version, it also picks up on whatever JDK that is on your path environment variable. So, and it also recognizes Java home environment variable, which I have already set up, Java home. So basically it also searches, and you can also define another variable called Maven home. So Maven _ home. You can also define that, basically pass it to this address. All right. And yeah, so again, Maven is a build tool. Maven understands how to build your system. You put your source files in the directories that Maven understands or expects, and then Maven calls the basically Java-C, the Java compiler, manages your dependencies, makes sure everything is on the class path, all the dependencies are available. So let's create a new package. Let's call it Java _native _image. And I'm just going to copy and paste that test class that we had. All right. So we're getting an error because we don't have that dependency on the other project. So for now, I'm going to leave it. I will show you how to add dependencies, internal dependencies. But for now, we're just printing something to the console. Hello world from Java, an external tool in a Maven project, right? All right. So everything is set. So we develop our Java code. We put our packages and all the Java classes source files inside the src main Java. If we have any resources, extra files, something like a text file or anything CSV file that our Java project requires, we put them in the src main resources. And then what we want to do right now, the target directory is empty, right? So if I open it up, because actually what happens, this integration, well, actually it's not empty. So the reason is that the way that Eclipse IDE supports Maven projects is that it uses Eclipse compiler to compile the Java files, but it recognizes that in Maven all the class files has to be in the target. So right now this let me hide up the hidden files. We have this target. Eclipse compiled this class file using its internal compiler, and then it creates the package hierarchy inside the classes, right? That's how this IDE Eclipse supports Maven projects. It recognizes where to put the packages and then the class files, right? But in general, you don't need to do that. Some IDEs don't use their internal compiler to compile the Maven project. So what you can do when you have a Maven project, if you right click, go to the run as, not only we have Java application, but we have Maven build, right? So and then now you can execute Maven commands, and those commands are passed to the Maven tool that is installed on your computer. Right now it says embedded 3.8.1. I don't want to use the embedded that comes with Eclipse. I want to use my external, and the external is let's edit this. 3.8.5 is the latest version. All right, finish, apply, and now it works fine. So we want to, by default, we want to use the external Maven tool that I have separately installed on my computer, because that's the latest version. And let's hit apply. Let's say we want to clean it. When you execute Maven clean command, it's going to clean, delete everything that is inside the target directory. So let's run this, and what you see here is that it's running the native image demo Maven clean plugin, deleting everything inside the target. So if I open up the target again, now this classes is empty. We deleted the automatic compilation that Eclipse had done, right? So if I run this, it's not going to, there is no class in here. So therefore there is no, Eclipse cannot execute it. If I make some changes and save it, Eclipse is most likely is going to recompile. So classes, now Eclipse quickly recompiled, and then this test class is available. And now if I right click and run it, it works, right? So basically Eclipse, every IDE has its own internal compiler. I mean, some IDEs might not, but most modern IDEs like Eclipse or IntelliJ, they have their own internal compiler. At least Eclipse does. And when they support a Maven project, basically Eclipse by default uses its own internal build, but puts it in where it's compatible with the Maven, right? It understands that this project has a Maven nature. And one thing here is that if you see it right now, the compatibility, it sets up, it's using JDK 17, but the compatibility is sets up to JDK 5, which means I cannot say var s is hello. Now Eclipse says that, remember the JDK is JDK 17, but the compatibility is by default with Maven projects inside Eclipse is set to JDK 5. That's why Eclipse is giving us a warning, right? So it says change project compliance and JRE to 10. So we can do that. And now the compliance is set to JDK 10, but I want to set it to JDK 17. So how do we do that? So we just go here and select JDK 17. And now this works. sysout X. And let's run this. It works fine, right? And if we do a sysout runtime.version, remember version is a static method, it tells me which JVM it's running on. It's running on 17, all right? But now let's say instead of using Eclipse, I want to use Maven to build my project. So what I'm going to do, I'm going to right click on my project, run as Maven build, and I'm going to tell it clean and then compile. Supply run. So it failed. So I cleaned up, emptied this directory, and it failed. So why did it fail? Because so it cleaned, it used the clean plugin, and then it used the compiler plugin, and then compiling this one source file, and then source option 5 is no longer supported, use 7 or later, build failed to execute the compiler on project this. It says use 7 or later. So why is that? We already set the compliance to 17. That's because Maven doesn't care, doesn't understand Eclipse projects. Maven only understands POM or POM file. So you have to give it properties, compiler, I guess it's maven.compiler.source, let's say 17, and then maven.compiler.target 17. If we save this and then try to rerun that command again, Maven build clean compile, let's see if this works. Now build successful. So basically, again, Maven, when you run the build your Maven project inside Eclipse, with the external Maven build, it doesn't understand the Eclipse project or anything. It just looks at the POM file, looks at the configurations, and then executes those. There are some dependencies here. We will talk about them later. And then you can also look at the POM file, right? So these properties, Maven compiler source, Maven compiler target. Again, these are a quick tutorial about Maven and how it works. And inside the Eclipse IDE, again, Eclipse uses its own internal compiler, but puts the class files at the correct location. Now, let's say we want to build an external tool for Maven, and I've already set something up here. Let's go back and use the most recent version of the GraalVM, 22.1, contents, home, lib, svm, and then bin directory, native image. This is the most latest version, 22.1.0, and I'm setting this to project location, target classes, right, working directory, and I want to select a Java file in my tree view inside Eclipse, and then I want the native image to basically, or the Eclipse to pass the class file, fully qualified name of the class file to that, and then I'm telling it to, remember, we are inside the working directory classes. So I want to go back up to project location. So to level up // and I want to go inside a native directory and then create the executable file there. So let's apply, let's close. So we want to create a directory which is not part of the Maven project. Let's call it a native. And then we're going to select our source file, and we're going to select our native image 17 Maven and run it. Let's see if this works fine. So right now a native image tells us, hey, I'm building this Java native image.test class. So initializing, building universe, parsing methods, inlining methods, compiling methods, and success, right? So it puts it in the native image demo, native Java native image. And if you look at our native, we do have a target. So if you open up a terminal here in this native, and if we say Java native image test class, it's going to work. Hello world from Java, hello world from Java and external tool in Maven project. Hello is this a string, and then 11.3 JVM CI. So this is running on top of the compact JVM that has been compiled to native binaries, right? So right now our external tool is successful for running basically Maven, compiling a Maven project. You have to point it to the classes. Now alternatively, as we mentioned, we can duplicate this and set it to project location, and then manually provide the -cp and then project class path, because even though this is a Maven project, Eclipse is aware. This is inside Eclipse, so Eclipse is aware of the project class path. All right, so let's rename this, or maybe let's copy and paste this to another name. Demo class. All right, so, and then we're going to select this. We're going to run our external tool, which we just duplicated. Now the class path is explicitly set. So let's run this, see if this is successful or not. GraalVM native image, generating Java native image.demo class, initializing. So let's wait a little bit. Let's see if everything goes fine. Performance analysis done. Building universes. Inlining methods. Compiling methods. And it failed. So there was an error linking the native image. So it says there was some error going on. Oh, that's okay. That's because, so we made a mistake. The mistake we made was we actually changed the working directory, and the problem is that when it was in the linking phase is when after compilation it tries to build the final binary, but this path was not correct, so it couldn't find this native image. So in the project location, we just have to tell it dot from the current working directory, which is project location, go inside the native and create the binary. Yeah, that was a mistake. So let's run this one more time. So this directory exists because the native image command is running from the root directory of the Java of this Maven project, native image demo. So the native directory is directly there. So when the linker creates the executable, it's able to find this native directory and puts the executable file there. All right, inlining methods, it's almost done, compiling, and after that the linker creates the executable file, and everything went well. So we have this, we already had a terminal open here. So let's see Java native image and then demo class, and it works fine. All right. So we're able to successfully create an external tool for a Maven project. Just note that the most important thing about Maven is dependency management, and Maven provides a very nice and easy way to manage all your dependencies. And then Eclipse IDE, when you have this Maven project inside the Eclipse IDE, it already is aware of all the dependencies. Therefore, it's very easy to set up this shell command so that all the dependencies are there, right? So in the next lecture, I will actually use Maven to add dependencies to this project, and then we will see what happens. And the nice thing about this configuration of the external tool, which we manually ask the Eclipse IDE to provide, basically substitute this variable project class path with all actual class path entries, and therefore we don't really need to change anything, even if we add lots of dependencies to this project. So please stay tuned, and I'll see you in the next one.